Good morning, students. Our topic for today is particle nature of electromagnetic radiations, Planck's quantum theory of radiations. The electromagnetic theory of radiations given by Maxwell failed to account for these phenomena. Number one, the nature of radiations which are emitted by black body, also known as black body radiations. These could not be explained by wave theory. Ejection of electrons from the surface of certain metals when light radiation strike the surface area. This effect is known as photoelectric effect. This also could not be explained by wave theory. The spectral lines emitted by certain elements, these are known as line spectrum and help in identification of elements. These also could not be explained with the wave theory of electromagnetic radiations. To explain these above phenomena, Max Planck in 1900 put forward a theory known as Planck's quantum theory. It regards that electromagnetic radiations are made up of particles. The main points are: the radiant energy is emitted or absorbed discontinuously in the form of small energy packets called quanta. In case of light, these energy packets are known as photons. The energy of each quantum is directly proportional to the frequency of radiation, that is, E is proportional to nu, or E is equal to h nu, where h is a constant introduced by Planck and it is known as Planck's constant. We can, because nu is c by lambda, we can also say E is equal to hc by lambda. Here h is a constant called Planck's constant and its value is 6.626 into 10 raised to power minus 34 joule second, or 3.99 into 10 raised to power minus 13 kilojoule second mole inverse. The total amount of energy emitted or absorbed by a body is some whole number or integral multiple of quantum. That is, one quantum was h nu, it will be E is equal to n h nu, where n is an integer, value can be 1, 2, 3, 4, etc. And the energy associated with Avogadro's, this is with one, energy associated with Avogadro's number of quanta is called Einstein of energy, E. Its value may be given as E is equal to n naught, Avogadro's number, into hc by lambda. So these were the points given by Planck's quantum theory. On the basis of the formula with which we arrive here, E is equal to h nu or hc by lambda, we can also solve numericals based on it. For example, this numerical states that calculate and compare the energies of two radiations, one with wavelength 800 picometer and the other with wavelength 400 picometer. So solution, first we write down the formula. E is equal to h nu is equal to hc by lambda. In the first case, lambda is 800 picometer, c is 3 into 10 raised to power 8 meters per second, and h is 6.626 into 10 raised to power minus 34 joule second. So energy will be hc by lambda, 6.626 into 10 raised to power minus 34 into 3 into 10 raised to power 8 meters per second upon 800 into 10 raised to power minus 12 meter. This comes out to be 2.48 into 10 raised to power minus 16 joules. In second case, lambda is 400 into 10 raised to power minus 12 meters. So E2 will be hc by lambda, 6.626 into 10 raised to power minus 34 into 3 into 10 raised to power 8 upon 400 into 10 raised to power minus 12. On solving, we get 4.96 into 10 raised to power minus 16 joules. So because we are also asked to compare the energies, so for comparison, E1 upon E2 will be 2.48 into 10 raised to power minus 16 upon 4.96 into 10 raised to power minus 16. This comes out to be 1 by 2. So E2 को ऊपर 2 को इधर ले गए तो E2 is equal to 2E1. So the energy in second case is double the energy in the first case.